Here we're going to talk about how to calculate energy. When we're calculating energy, we're mostly going to focus on phase diagrams. We're changing from different phases to another phase. So here, we are going to talk about the three different equations. So if we're here, we're talking about how heat equals the mass times specific heat times change temperature. This is the one we've used before. We have already used this. This Q could be a lowercase q, which we've shown before in a different equation. It was just a lowercase q. We just capitalized it because it was the first thing on there. So we can just go ahead and change this to lowercase q's. So it's just the energy or the heat that's being released. This is what you do when you're changing the temperature. So we're changing, if an ice is changing from -4 degree ice to 0 degrees ice, this is what we're going to use. If we're changing a liquid from 5 degrees Celsius to 95 degrees Celsius, we'd use this one. But when we are changing its phase, when we're changing a state of matter, we can no longer use this because it's not changing its temperature, it's changing its phase. Remember we had our phase diagram? Bloop, bloop, bloop. Okay? Right here, it's not changing its temperature, but it is taking more energy, more heat to do so. So there has to be a different equation. It's very easy. We're going to take the moles times the heat of fusion. This is something that is specific for each different substance, and there's a chart on the next slide. Also, if that is for fusion. Again, fusion is where it's melting. Okay, so fusion is melting. And then we're going from a heat, is where the heat can also be calculated by moles times the heat of vaporization. This is when it's vaporizing. So this is liquid to a gas, and this is a solid to a liquid. These are the different ways to go, the different energy that's required. If it was going the other direction, it would just be negative. All right, let's go ahead and show you the chart. So some things to know is that water is, talk about this a lot, 1 gram per milliliter. So if you have 1 gram, 1 milliliter, if you have 1,000 grams, you have 1,000 milliliters. So make sure if you have 675 grams, you have 675 milliliters. Very important to know. So we're also, when we're doing this, we can change. So the total heat is the sum of all of the heat you have to use. So if you're going from if you're starting as an ice, okay, we're going to show you a problem. We're going to start, if you're starting as ice below 0 degrees Celsius, you're going to have to add the ice it takes to get to 0 degrees Celsius. You have to add the heat it's going to take to get 0 degrees Celsius. Then, if you're going to then change to water, you have to then add the heat of fusion that you're going to get to make it a water. Then anytime you're going from anywhere in water to a different temperature, you're going to have to add that energy until you get to if you boil, and if you're going to steam, it's higher temperature is that as well. Let's do an example. I think it'll make more sense once we do an example. All right, so our first example, an only example right now, will be, we want to know how much heat does it take to heat 12 grams of ice at -6 degrees Celsius and 25 degrees Celsius. So this is one of the equations we're going to use. We're also going to use Q equals a number of moles times our heat of fusion. Because we're trying to go from ice to water. So a solid to a liquid. So that's why we're going to use the heat of fusion. We're going to have to add these two together. So let's go ahead and start with this one. We want to get our 12 grams of ice to 0 degrees of ice. Because we have to just change it to ice. Okay, we have to change our 0 degrees of ice. So we're going to start with Q equals our mass, which was 12 grams, times our specific heat. So this is different. Our specific heat for ice is going to be different than our specific heat for water. If we go back in our notes to our specific heat section, it was covered. Find it. Here's our specific heat. So our specific heat we want for not liquid water, ice, right here. We want to do it for ice, and let's go ahead and keep it all in joules. So we're going to use the 2.1. So make sure you're using the one for ice, not liquid water. They are different specific heats. So let's go back where we were at. All right, so now we have that times our specific heat times our change of temperature. So we're going to go, our initial temperature is a -6 degrees. That's our initial. So delta T equals temperature final minus temperature initial. So you have -6 degrees, and the way to get it to change from a solid to a liquid is you have to be at 0 degrees Celsius. So we're going to say 0 degrees Celsius, we're going to minus that. So really, our delta T is equal to 6, because a negative minus negative equals positive. So we're going to change 6 degrees. So we're going to go ahead and take a calculator. 12 times 2.1 times 6. This is going to equal 151.2 joules. This is our first then we only need 2 sig figs, so 7 moles. And then we're going to take this times our fusion, which was 2 slides back, and we want the heat of fusion for water, so 6.02. So we're going to take, for this right here, 0.67 times by our heat of fusion, which I forgot already, 6.01. Alright, now that we have this, we can now then times this together to get our second Q. So that times 6.01. So Q will equal 4.0 joules. Our second. So now we have how much energy. This is how it got. This is how we go from 0 degrees Celsius to, or negative 6 degrees Celsius to 0 degrees Celsius. That's how you go from that. And here we're going from a solid to a liquid. Now that we're a liquid, we're at 0 degrees of our liquid. So we have to get from 0 degrees of our liquid to 25 degrees of our liquid. So we're going to use this one again. We're going to use Q equals mc delta T. So we know our mass was 12. Our C for water. Now we're a liquid water. We have to find our specific heat of liquid water. I believe it's 4. Let's go back just to double check. Our specific heat of liquid water was 4.18. Again, you guys have this chart inside of your guys' notes. And we're going to times it by the delta T. Our initial was 0 degrees Celsius. And our final is 25. So 25 minus 0. So our delta T will be 25. Just go back to the slide so it's a little easier to read. Now all I have to do is plug this into our calculator. Let's be lovely. 12 times 4.18 times 25 will give us 1,254 joules. And this is how we got from 0 degrees Celsius to 25 degrees Celsius. So again, this is because on our phase diagram chart, you have to take into account all of these steps. We have taken this from here to here. We used 151.2 joules. From here to here, we used 4 joules. And then from here to here, wherever we got for 25 degrees Celsius, we used 1,254 joules. So now we have to know how many joules we got from here to here. We want to know what the total was between these two. So we're going to add all of the different numbers up. So we're going to take this number plus our 4 plus 151.2. So you're going to take all of those and add them together. And your final answer will be add together. And our final answer is 1,409.2 joules. Again, we usually say this in kilojoules, so it will be 1.4 kilojoules. And that is how we do this. Multiple steps. Don't worry about practice a little more in class, but there's multiple steps here, and we have to make sure we're calculating how to do it all the way out. All right, thank you. Ask me questions in class.